Okay friends, welcome to Login Science. Today's video will be on Hyperbola grade 12 or Hyperbolic function grade 12. Okay, so this is part 3 of 6. Part 4 of 6 will be on exponential function. Okay, so for now it is Hyperbola grade 12, which is part 3 of 6. Okay, let's get started. We start with the standard equation of a hyperbola. Okay, so this is the equation that you have to know. So this is the standard equation of a hyperbola. You have y is equal to a over x minus b plus q. Okay, so this equation, sometimes it can be given as a over x minus b plus c. Instead of p, you can have b there. Instead of q, you can have c. So it doesn't matter. The equation is still the same. So this is the standard equation of a hyperbola. Okay, we are going to see that. We are going to see 4 examples that I believe will help you to understand the standard equation of a hyperbola. Okay, we start with a situation when p is equal to 0 and q is also equal to 0. Okay, so when this p and the q are equal to 0. Example, you have y is equal to 2 over x. Okay, you can see your p and q are not there. So p and q are equal to 0. So let's start with this example and try to understand how the equation of a hyperbola works. Okay, so for this example, you can have a graph like this one. You can see. So this is the graph of y is equal to 2 over x. This is the graph. So we are going to analyze this equation when p and q are equal to 0. We want to understand how it works. Okay, let's start with this example. Okay, in this example, we can see when p is 0, the y-axis acts as the vertical asymptote. So you have to understand that the value of p will tell you what is your vertical asymptote. But if you have the value of p being 0, as in this case, now the y-axis acts as the vertical asymptote. You can see this is the y-axis. Now it's acting as the vertical asymptote. Okay, what you have to notice here is that when p is 0, the y-axis is now your vertical asymptote. And the hyperbola does not have the y-intercept. Can you see that? Because if the y-axis is acting as the vertical asymptote, obviously the hyperbola does not have the y-intercept. And when the value of q is 0. Now when the value of q, you can see there is no q there. So the value of q is 0. When q is 0, the x-axis acts as the horizontal asymptote. Okay, the value of q will tell you what is the horizontal asymptote. But if q is equal to 0, as in this case q is 0, you can see there is no q, so q is 0. When q is 0, the x-axis acts as the horizontal asymptote. And again, the hyperbola does not have the x-intercept because now the x-axis is acting as the horizontal asymptote. So this hyperbola is not going to cut the x-axis. So the hyperbola will not have the x-intercept because the value of q is 0 and the x-axis acts as the horizontal asymptote. Okay, let's carry on. So now, how to decide in which quadrant the hyperbola is? How can you decide in which quadrant the hyperbola is? You don't need to memorize this. You have to understand this. It is simple. Okay, I don't want you to memorize this. You have to understand this. Because if you memorize, you are going to forget it. But you have to understand how to find in which quadrant the hyperbola is. Okay, this is what? This is your a. You can see you have a there in the equation of hyperbola. In this example, your a is equal to 2. Okay, when the value of a is greater than 0, that means the value of a is positive. When the value of a is positive or the value of a is greater than 0, you have to think of a line with positive gradient. Okay, when the value of a is positive, think of a line with positive gradient. That is a line which is increasing or a line which is rising. So to do that, you have to identify your horizontal asymptote first and your vertical asymptote. Okay, after you identify your horizontal asymptote and your vertical asymptote, now you have 4 quadrants. You can see 1, 2, 3, 4. Okay, the quadrants are always formed by the vertical asymptote and the horizontal asymptote. Okay, now you are going to draw what? the line with positive gradient, because a is greater than 0. Greater than 0 means positive. You are going to draw a line with positive gradient in such a way that it passes through that intersection. So this is the line with positive gradient. Okay, the gradient of this line is positive, right? M is the gradient. So the gradient of this line is positive. Now you can see this line is in this quadrant and in this quadrant. This is the first quadrant, right? And this is the third quadrant. Okay, you have first, second, third, and fourth. Okay, when it is positive, you draw an increasing line, and you can see it is in the first and third quadrant, and even your hyperbola will be in the first and third quadrant. You can see in this example the value of a is 2. This is positive, right? This is greater than 0, so this means it is positive. You can see the hyperbola is in the first and third quadrant. Okay, so you can see that, and you can see that the quadrants are formed by the x-axis and the y-axis. We have 4 quadrants there. Okay, in this situation, your asymptotes are the x-axis and the y-axis. These are your asymptotes. When now the value of a is less than 0, this means the value of a is negative, right? You have to think of a line with negative gradient. Okay, this is what a decreasing line. Okay, you identify first your horizontal asymptote and you identify your vertical asymptote. Now you know what your quadrants are. Okay, think of a line with negative gradient. This is the line with negative gradient. You can see it is decreasing or falling, right? So the gradient of this line is negative, right? And you can see it is in the second and fourth quadrant, right? This is the first, second, third, and fourth. And even a hyperbola with the value of a negative is going to be in the second and fourth quadrant. This is simple. You don't need to memorize this. Another thing that you have to know about a hyperbola is that a hyperbola has got 2 axes of symmetry. Okay, a hyperbola has got 2 axes of symmetry. We are going to see that there is one with positive gradient. The gradient is always equal to 1. Okay, so the 2 axes of symmetry, there is one with positive gradient. The gradient is always equal to 1. Okay, so you have this, which is the axis of symmetry. The gradient of this line is equal to 1. It is always 1. This is the axis of symmetry, the one with positive gradient. The gradient is always equal to 1. Okay, there is another one. There is the one with negative gradient. Okay, the gradient is always equal to -1. Okay, this one, right? The gradient is always equal to -1. So you can see a hyperbola has got 2 axes of symmetry. This one with positive gradient, the gradient is always equal to 1. And this one with negative gradient, the gradient is equal to -1. Okay, you can see if you try to fold the hyperbola around this axis, you can see this part is going to lie exactly on top of this part if you try to fold the hyperbola around this axis. Okay, or you can try to fold the hyperbola around this axis. You can see this part is going to lie exactly on top of this part. Even this part is going to lie exactly on top of this part if you try to fold the hyperbola around this axis of symmetry. Okay, so let's carry on. Now, the 2 axes of symmetry always intercept at the point where the horizontal and vertical asymptotes intercept. The 2 axes of symmetry, this one and this one, always intercept at the point where the horizontal and vertical asymptotes intercept. Okay, you have your horizontal and vertical asymptote in this example, right? Which are your x-axis and your y-axis. They intercept at that point. Even the axis of symmetry, this one and this one, they also intercept at that point. This is always the case. The axis of symmetry will always intercept at the point where the horizontal and vertical asymptote intercept. Okay, and remember, you have to identify first your horizontal asymptote and your vertical asymptote. In this case, your vertical and horizontal asymptote are the x-axis and the y-axis. It is not always the case. We are going to see another example where the x-axis and the y-axis are not asymptote. Okay, now to get the domain of this hyperbola. The domain is always found on the x-axis. You take all the values of x that exist for this hyperbola. Okay, you are going to get your domain starting from left to the right, always from left to the right. So you take all the values of x that exist for this hyperbola. So you have x element of real numbers. Okay, all these values, they exist for this hyperbola, but there is a break. Can you see there is a discontinuity at 0? Can you see x is equal to 0 there? The hyperbola is not joined, it's broken. You can see it deviates, right? And after that you have the hyperbola again. Okay, at x is equal to 0, there is a break, it's broken. Okay, so x is not equal to 0. So this is not part of the domain. So you have all real numbers, but you exclude 0, right? Because there is a break at 0. Okay, you can give the domain like this, or you can say x element from left, you have negative infinity. So you have this bracket, you can give it as a bracket, negative infinity, all the way to 0. There is a break there. And then union from 0 all the way to positive infinity. Okay, you do it like this, or you can give the domain like this: x less than 0, you have all these values which are less than 0, or x greater than 0. Okay, again 0 is excluded. This is why you don't have equal there, you don't have an equal there, because 0 is excluded from the domain. So you can give the domain like this, or like this, or like this. Okay, you have 3 ways in which you can give the domain of this hyperbola. How about the range? Let's see that. The range is obtained on the y-axis. You take all the values of y that exist for this hyperbola. You always start from the bottom to the top when you take the range. When you take the domain, you start from the left to the right. But when you take the range, it is always from the bottom to the top. Okay, so you have y element of real numbers, but you exclude 0. There is a break at y is equal to 0. Can you see this break? It's broken there. The hyperbola is not joined. So when you start from the bottom at 0 there, it's broken, and then after 0 you now continue. Okay, so you have all the values of y, so real numbers, but y is not equal to 0. You exclude y is equal to 0 because there is a break there, there is a discontinuity there. Okay, so you have the range given like this, or you can give it as y element of this interval. From the bottom you have negative infinity all the way to 0, where you have a discontinuity. Union, now you start from 0 all the way to the top, which is positive infinity. Okay, you can give the range like this, or you can say y less than 0. You have all these values less than 0. Or y greater than 0. You have all these values above 0, so greater than 0. Okay, so you have 3 ways in which you can give the range of this hyperbola. Okay, the 3 ways are given there. Okay, you don't have to give all the 3 ways. Just choose one and give as an answer when they ask you to give the range of a hyperbola. You also have 3 ways in which you can give the domain of this hyperbola. Just choose one and give as an answer when they ask you to give the domain of this hyperbola. Okay, let's move on and see another example. Okay, we still have the standard equation of a hyperbola. This is the standard equation of a hyperbola. Okay, this one. Okay, now we have an example when P is not equal to 0 and Q is equal to 0. Right? We are going to see this example. For example, you have this: y is equal to negative 2 over x minus 3. You can now see that the value of P is not equal to 0, right? The value of P is equal to negative 3, right? P is not equal to 0, P is equal to negative 3. Q is equal to 0. You don't have Q there, right? Q is equal to 0. So let's see this example. Okay, so if you have to draw this graph, it's going to be like this. Okay, we are going to analyze it. So this is the graph of what? y is equal to negative 2 over x minus 3. Okay, so this is the graph. Now, when p is not equal to 0, you now have the hyperbola has got what? A vertical asymptote that is no longer the y-axis. Okay, you can see that when p is equal to 0, the y-axis is acting as what? As the vertical asymptote. But p is not equal to 0. Now you have a vertical asymptote which is no longer what? The y-axis. So you have the vertical asymptote there. Okay, we are going to see how to get it. Okay, to get the vertical asymptote, this is what you have to do. You take what you have there in the denominator there. You have x minus 3. You take what you have there to get your vertical asymptote. So you have x minus 3. You equate it to 0 and you solve for x. In this case, x is equal to 3. When you take negative 3 to the right, x is equal to 3. Okay, so the vertical asymptote is at x is equal to 3. You can see x is equal to 3. This is what? Your vertical asymptote. This is how you get the vertical asymptote. Always take what you have in the denominator there, equate it to 0 and solve for x. Okay, so why do I equate this to 0? Because if you have division by 0, you are going to have an error in your calculator. When you have an error in your calculator, that's when you can have the vertical asymptote. Now, you have to see that the hyperbola has now the y-intercept. Okay, you can see it cutting the y-axis at that point. Okay, because the y-axis is no longer acting as what? As the vertical asymptote. Now the hyperbola can intercept the y-axis. You now have what? The y-intercept, because the y-axis is no longer the vertical asymptote. This is your vertical asymptote. The y-axis is no longer what? The vertical asymptote. And this is why the hyperbola can cut the y-axis. You now have a y-intercept. Okay, to get the y-intercept, you let x equal to 0. To get the y-intercept, you let x equal to 0. If you want to get the domain of this hyperbola, you can see the domain is found on the x-axis. You take all the values of x that exist for this hyperbola, but you exclude 3. You can see there is a break at 3, right? There is a discontinuity at x is equal to 3. So the domain of this hyperbola is x, element of real numbers, but x is not equal to 3. Because there is a break there. You have that vertical asymptote at 3. Or you can write it as x element. You start from the left. You always start from the left to the right. From the left, you have negative infinity. This hyperbola does not stop here. It still continues, right, to infinity. So from the left, you have negative infinity all the way to 3, where it's broken. You close the bracket. Union. Now from 3 all the way to the right, which is positive infinity. Okay, this is simple, right? Or you can give it as x less than 3. You have all these values less than 3. Or x greater than 3. Like this. Okay, so you don't have an equal sign there, because 3 is not part of the domain. This is why you don't have an equal sign there. And this is why you have a round bracket there, because 3 is not part of the domain. So you have 3 ways in which you can give the domain of this hyperbola. Okay, what about the range? The range is obtained on the y-axis. You take all the values of y that exist for this graph. Okay, so you have all these values. You can see when you start from the bottom, all these values, but it's broken at y is equal to 0. You can see it's broken there. There is a discontinuity at y is equal to 0. So you start from the bottom to the top. So all real numbers. So y, element of real numbers, but y is not equal to what? To 0, because there is a break at 0 there. At y is equal to 0. Or you can say y, element of what? You always start from the bottom to the top when you take the range. From the bottom, you have negative infinity. So you have a round bracket because you don't know what infinity is. So from the bottom, it's negative infinity all the way to there where you have a discontinuity at 0. Okay? you close a round bracket to show that 0 is not part of the range. Union means plus, okay? You start from 0 all the way to the top. You can see this graph still continue. It doesn't stop here, still continue to infinity. So it's from 0 there, right, to infinity, and you have a round bracket because you don't know what infinity is. You still continue, okay? Or you can give the range like this: y less than 0. You have less than 0, or y greater than 0, okay? You don't have an equal sign there because 0 is excluded. 0 is not part of the range. This is why you don't have an equal sign there. And this is why you have a round bracket there to show that 0 is excluded. So you have 3 ways in which you can give the range, and you have 3 ways in which you can give the domain. Just give one, okay? You don't have to give all the 3. Okay, now let's continue to the next slide. Let's see another example. Okay, we still have the standard equation of a hyperbola. Okay, this is the equation, right? This is the standard equation of a hyperbola. Now we have a situation when P is equal to 0 and Q is not equal to 0. Okay, example, you have this y is equal to 2 over x minus 1. Now you can see the value of Q is minus 1, and P, you don't have P there, so P is equal to 0. Okay, so if you have to draw the graph of this equation, it's going to look like this. Okay, so this is the graph of y is equal to 2 over x minus 1. So let's analyze this graph and understand what the P, Q, and A do to the equation of a hyperbola. Okay, so when the value of Q is not equal to 0, the value of Q is going to tell you what the horizontal asymptote is. But when Q is not equal to 0, in this case you can see Q is equal to -1. When Q is not equal to 0, the hyperbola has a horizontal asymptote that is no longer the x-axis. Okay, so the value of Q is going to tell you what the horizontal asymptote is. When Q is 0, the x-axis is going to act as what? As the horizontal asymptote. But when Q is not equal to 0, the hyperbola has got a horizontal asymptote that is no longer what? The x-axis. Okay, in this example, the horizontal asymptote is at y is equal to -1. Okay, the value of Q is going to tell you what the horizontal asymptote is. So at -1 there, you have the horizontal asymptote. You can see the value of Q is -1. So at y is equal to -1, you have the horizontal asymptote. If Q is equal to 0, the x-axis will be your horizontal asymptote. But when Q is not equal to 0, now the hyperbola has got the x-intercept. You can see the hyperbola is cutting the x-axis. You can see this is the x-intercept because Q is not equal to 0. So to get the x-intercept, you let y equal to 0. Okay, we still have the standard equation of a hyperbola. This is the equation. Okay, like I said, you can have B instead of P. You can have C there instead of Q. It doesn't change, it's still the same. Okay, so this is the standard equation of a hyperbola. Okay, now we have a situation when P is not equal to 0 and Q is also not equal to 0. Let's see that. Example, you have this y is equal to this 3 over x plus 4 plus 5. You can see the value of Q is equal to 5 and the value of P is equal to 4. Okay, so P is not equal to 0 and Q is not equal to 0. Let's see this example. So if you have to draw this hyperbola, you are going to have something like this. Okay, let's see that. So this is the hyperbola of what? Of y is equal to this, right? Okay, so when P is not equal to 0, again, the hyperbola has got what? Has got a vertical asymptote that is no longer what? The y-axis. Okay, to get the vertical asymptote, always take this, what you have in the denominator there. You have x plus 4, you equate it to 0, and you solve for x. X is equal to, you take this to the right, you have -4. Okay, you can see at -4, you have this vertical asymptote at x is equal to -4. So the equation of this vertical asymptote is x is equal to -4. This is how you can get the vertical asymptote. Take whatever you have in the denominator there, equate it to 0 and solve for x. As simple as that. Do not try to memorize this. Okay, now you can see when the y-axis is no longer acting as what? As the vertical asymptote, you now have what? You can see the hyperbola is cutting the y-axis at that point. So the hyperbola has got now the y-intercept. Okay, so to get the y-intercept, you know this, you let x equal to 0. What about the value of q? When q is not equal to 0, the hyperbola has got a horizontal asymptote that is no longer the x-axis. If q is 0, this x-axis is going to act as what? As the horizontal asymptote. But in this case, q is not equal to 0. Q is 5. So the hyperbola has got a different horizontal asymptote that is no longer the x-axis, right? Okay, you can see the horizontal asymptote in this example is, the horizontal asymptote is y is equal to 5 to that value. This is how you get the horizontal asymptote. You take that value, y is equal to that value. So the hyperbola has now the x-intercept. So because q is not equal to 0, the hyperbola has got now the x-intercept. To get the x-intercept, you know it, you let your y equal to 0. Okay, again, remember when the value of p is positive, as in this case, the value of p is positive, the hyperbola shifts p unit to the left. You can see this hyperbola has shifted to the left from 0 to -4. So to the left, when p is positive, the hyperbola shifts to the left. When p is negative, the hyperbola shifts p unit to the right. Okay, so this is everything I prepared about Hyperbola grade 12 or Hyperbolic function grade 12. Okay, please check for part 4 of 6, which will be on exponential function. Okay, for now we are done. If you find value in this video, please show that with your likes, comment in the comment section. Remember to subscribe and activate the notification bell so that you can be alerted whenever a new video is posted on the channel. Until next time, I will talk to you soon.